To do here now, yeah, he started recording.
Okay.
So, no problem.
I will stop the recording just now.
Gentlemen, good morning, good afternoon, and good evening for whom who's going or for whom is joining us from outside Saudi Arabia. Thank you for attending this webinar and this very interactive session where we are going to learn more about artificial intelligence. With you here, Hazim Al Khayat, and I'm going to be the host of this session. I come up, I have joined this session as a host, and I'm a volunteer member with the Project Management Institute KSA chapter. I bring with me more than 15 years of experience in project management, and I would like to thank our speakers here who are very keen in artificial intelligence. We are having Mr. Ron and Mrs. Kathleen, who are going to deliver a very fruitful session about what you need to know today to successfully run and manage AI project. For the time being, I would like to just introduce our speakers, Mr. Ron and Mrs. Kathleen. They are managing partners and cognitive project management for artificial intelligence. They have co-developed the cognitive project management, which is used by Fortune 1000 firms and government agencies worldwide to successfully run and manage their AI and advanced data projects. This methodology has been adopted by so many multinational organizations in order to manage their AI projects. And here, from this platform, I would like to welcome Mr. Ron and Mrs. Kathleen. You are welcome, and thank you for accepting our invitation. And we are eager to know more about what we need to do today in order to run and manage AI projects successfully. Floors is yours, and I wish everybody is going to learn more and more about how to run and manage AI projects. Floor is yours, Mr. Ron and Mrs. Kathleen.
Well, thank you all so much, and really want to say a big thank you to all of you for inviting us to present and participate in this community. There's a fantastic registration list, so it seems like a lot of folks are really interested. And well, we're going to help you understand some more about AI projects, why AI projects are failing in many cases, and of course, the processes and methods we use to make AI projects a success. And by real way of quick introduction, I'm Ron Schmelzer. I'm a managing partner here at Cognilytica, and I'm joined here by my partner, managing partner, and cohort at Cognilytica, Kathleen Walsh.
Yes, hello, everybody. I'm Kathleen Walsh. I'm also a managing partner here at Cognilytica. We are an AI-focused research, advisory, and education firm. We have been around for a number of years now, since 2017. We're co-creators of the Cognitive Project Management for AI, CPMAI methodology, which we'll talk about more at the end of today's presentation. We're also hosts of the AI Today podcast. We've been going strong for 7 years now. We have over 400 episodes. So you can go to aitoday.live to listen to them. We have interviews with luminaries in this space. We have interviews with CPMAI certified individuals. We also have a use case series and a generative AI series that we are in the middle of right now. So we have lots of different ones. So I encourage you to listen if you're interested. We're contributing writers to Forbes and Tech Target. I am a member of the OECD's One AI working group, and we actually were just, both of us, invited to be on their Trustworthy AI group. And we're also top AI voices on LinkedIn. So just a quick background about us.
So I think like the first insight that we can provide is that AI systems have a high rate of failure. You might have read in the press that something like 80+% of AI projects fail. And when we mean fail, that means usually that they're not delivering what they're supposed to deliver. Many AI projects get canceled or run into some sort of problems, some sort of sometimes legal, ethical, other problems. And you might say, well, you know, many technology projects especially have some sort of high rate of failure. This is not necessarily specific to AI. But what makes AI sort of unique is that we have to remember that we're asking machines to do things that are not what we have asked them to do before. I mean, if you think about it, one of the primary problems that we're trying to solve with AI is that if we could just program a machine to do something, we can use human intelligence to basically write a program, to create rules, to do whatever we want machines to do. And machines are really good at taking our instruction and doing exactly what we want them to do. On the flip side, of course, we can have a person, we can have that person do what we want them to do too, and they can use their intelligence that they've been, given. They have this great mind, and they can use that intelligence to make decisions, understand the world around them, do all these sorts of things. We call the 3 Ps of intelligence: perception, prediction, and planning. But with AI, we're actually trying to get machines to do some of those things that humans were previously able to do, the perception, prediction, and planning. And the thing about AI systems is that we use AI when we can't do programming, because otherwise we would use programming. So that means that by definition, we want AI systems to do some of the harder problems. We want them to do things that have a high degree of variability, and therefore we have AI systems that don't always provide things in the same consistent way.
Exactly. And so we have seen a number of different reasons why AI projects fail. And we always think that you can learn more from failures, than you can from successes, because you can see where people made mistakes or things went wrong so that you can adjust for that and not do it yourself. So one of the common reasons we see AI projects fail is that AI projects are not like traditional software development projects. If you've ever worked on an AI project, then you know that they really are data projects. So if you're running your AI projects like you're running application development projects, you're going to very quickly realize, or maybe not quickly, and that's the unfortunate part, which is why it can fail, but you will find out the hard way that it just won't work. Because AI applications really aren't very code dependent. Yes, there's a little bit of code, but that's really not the hard part. The hard part is data. So if we know that AI projects are not like software application development projects, then we need to say, okay, well, they are data projects, but what are they like? Because AI is an umbrella term. And so I may be talking about AI-enabled chatbots. Ron may be talking about an autonomous vehicle. Somebody else may be talking about computer vision. And they all fall under the term artificial intelligence, but they are not all the same. So a few years ago, we actually developed the 7 patterns of AI, because it's a way to break down one level further what these AI applications are. And actually, right before the pandemic in February of 2020, I went to Paris to present at the OECD, the Organization for Economic Cooperation and Development, to an international audience on the 7 patterns. And the OECD has adopted the 7 patterns of AI as their definition of AI. And now the EU AI Act has adopted that as their definition of AI, because despite the term being coined in 1956, artificial intelligence, there is no commonly accepted definition.
Yeah, and I think one of the things that we realized is that when 2 different people are talking about AI, they might be talking in general about machines doing the things that they do with machine learning, as I mentioned, perception, prediction, and planning, but the actual application might be very different. It's one thing to talk about using AI for, say, autonomous vehicles. It's another thing to be using AI for, say, chatbots or for recognition systems. And so that was the first thing, that was the tip off, the clue that we were dealing with some complexity with AI, because the projects look very different when you're trying to build, say, a conversational system than when you're trying to build a recognition system or a predictive analytics system or an autonomous vehicle system. The autonomous patterns are actually some of the hardest patterns to do. So one of the things that we did back in 2017, when this work was first developed, is research in conjunction with a large bank and large government institution, when we were trying to make AI projects work with a high rate of success, because the penalties for failure were pretty big if we got it wrong, is that we decided to divide the pattern AI into not just the general topic of AI, but into these different patterns, these application areas that were specific to the kinds of projects people were running. Because once we knew what pattern we were doing, then we could basically accelerate the project. So maybe Kathleen, want to go over at a high level the patterns, then we'll get into some of the other challenges of AI.
Sure. So We created it as a wheel because there is no hierarchy and one pattern is not more important than the other. So presenting in no particular order, the hyper-personalization pattern is treating each individual as an individual. So no longer do you have to bucket people into groups and categories. You can treat each person as an individual. So you think about this as a marketer's dream, right? They are able to target the right person at the right time with the right message. But also you can apply this to hyper-personalized education or hyper-personalized healthcare or hyper-personalized finance. So just because two people may have the same spending habits doesn't mean that, their salaries are the same or their savings need to be the same, or they may be at the same stage in life and they have, different needs. Now we can treat them individually. The next pattern is the recognition pattern. So this is making sense of unstructured data. So we think about all of the data that we have in an organization, and 80+% of it is going to be unstructured. So we think about emails and voicemails, video files, audio files, all of that is unstructured. So the recognition pattern helps make sense of that, which at the end of the day is, if we want to gain additional insights on that data, we need a way to do that. An example in this pattern is image recognition or facial recognition. Then we have our conversation and human interaction pattern. This is machines and humans interacting with each other in the language of humans. So we think about chatbots, for example, or maybe large language models in this pattern. Then we have predictive analytics and decision support. So this is taking past or current data and helping humans make better decisions. So the human isn't removed from the loop in this pattern, but it just helps them make better decisions. We call it augment their job or their role or whatever it is they're doing. Then we have goal-driven systems. So this is really around reinforcement learning and finding the most optimal solution to the path. Think about this for game playing. It's really used heavily here, but another example could be robo-advising. Then we have our autonomous systems pattern. So the goal of this pattern is to fully remove the human from the loop. Whenever you're trying to remove the human from the loop, it's going to be very difficult. This is one of the most difficult patterns of AI. We think about this with physical items. So, vehicles, for example, autonomous vehicles, but then we can also think about this as related to software, and you can have autonomous, business processes that maybe help, route something through your organization automatically. And the last pattern is patterns and anomalies. So machines are really good at looking at large amounts of data and being able to process that very quickly, much faster than humans. So the machine is able to look for patterns and spot trends and also find outliers or anomalies. We think about this with fraud detection, for example. So this just helps you break down at a, one level lower what you're trying to solve. Whatever you're trying to do, it can be more than one pattern of AI. It doesn't have to be just one pattern. So that's also important to understand, but you can break it down and do it pattern by pattern. And we'll get into that in some examples.
Yep. So it sort of brings us to one of the challenges with AI, that we're trying to get these intelligent systems to do things that perhaps we could not have done otherwise with automation or straight programming or just have a person do. And therefore, we get into this trap where we might be implementing AI with not a very well-defined business problem. We might be overspending on the AI system and not getting the return. It's a very common problem with AI systems. As we like to say, people fall in love with the idea of AI. They see things like, oh, look at this amazing stuff I can do with, ChatGPT, or what I can do with the system. And they start to think of they get inspired by all these things. And then all of a sudden we're seeing AI being applied to things where they probably should not be applied. And then we don't see any business return. And I think that's why we need to start with any good project, to start with, well, what's the problem we're trying to solve? And in the case of AI, we need to ask a second question, which is, how can AI specifically solve this problem in ways that other approaches that are non-AI can't, or in ways that AI will provide a better return? So of course, we talk about cost savings, or saving time, or saving resources that we might have scarce resources, might make better use of them with AI, or improving compliance or safety, security, or just customer satisfaction, whatever the need is. If we've identified we have this need, then we say, well, how is AI going to specifically help address that problem point? Because if you can address it and you could show it, then you'll have a high rate of success. Otherwise, you're just kind of doing AI for no really good reason. What's called doing AI for fear of missing out, the FOMO reason. or a lack of a real purpose. We always say, you need to really have a look at other alternatives because the other alternatives may work. We see a lot of times people confuse automation with intelligence. They're not really the same thing because you're trying to do different things. With automation, we want repeatability. We want repetitiveness. We want to be able to have a high rate of predictability. If we think about someone says, hey, you're acting very much like a robot, that probably doesn't mean you're being intelligent. That just means you're acting very sort of programmatically, repetitively. Being intelligent means handling variability, handling variety, handling unseen use cases that may never have seen before. So we want variability and variety with intelligence, but with automation, we want repeatability, we want predictability. So one of the examples that we gave here is that, Walmart had the large retail shopping chain here in the US. They had this bot that they would use to scan the store shelves for inventory because it would take people a long time to do the inventory, and it was a task they had to do on a repeated basis. So what they did is they invested in this bot that would sort of automatically go down the store shelves and scan all the items and check to see if they match the quantity on stock, etc. Well, as you can see here from this article, we like to bring in what's called ripped from the headlines, real world examples. We don't have to make anything up because the real world has plenty of examples. They had to actually gave up on the contract. The project was a failure and they didn't continue it. Well, if you think about it, we just told you about the 7 patterns of AI. So you have to ask, well, what were the patterns of AI that we were doing with this inventory scanning bot? It turns out we were doing at least 2 patterns. One pattern was the recognition pattern, which is the pattern of trying to get the machine system to recognize using images what was on the store shelf. So that's pattern 1. But pattern 2 was you had the autonomous pattern, which was basically navigating the store shelves and moving around the system. And we told you that's actually the hardest pattern, one of the hardest patterns to do. And of course, we were trying to solve 2 problems at the same time, the recognition problem and the autonomous problem. But of course, we'll tell you with the methodology, you're supposed to solve 1 pattern at a time and usually start with the first pattern that will basically be the fastest to implement that will also address your problem point first. What they could have done instead of having this autonomous robot is they could have had a camera on, say, a shopping cart that an employee would push down the aisle, and they could scan all the items in that store shelf. They didn't need to deal with the autonomous part. They could have just dealt with the recognition part. If you think about it, that is, you're using the machine what the machine is good at, which is counting things and using image recognition because people take time for us to do that. And you could use what the human is good at, which is walking and navigating the store shelves. What they could have also done was scoped the project, which we'll talk a bit later. They didn't have to do the whole store. They could have focused on 1 aisle. And this would have probably led them to success. They wouldn't have had to cancel the project. And then maybe later they could have dealt with the autonomous pattern, but that would have, you had to ask, well, what problem are we solving with doing something autonomously that we couldn't do with the employee pushing the cart down the shelf? So, a very good question. And that's why you should start always with that problem.
Exactly. So we talked about how AI projects are really data projects. So then it should come as no surprise that data quantity, the amount that you have, and data quality, how good it is, are going to be other reasons why we've seen failure. The old saying goes, garbage in is garbage out, and it really is no different with AI, especially because they're trained on data. So when it comes to data quantity, this is how much data should you have? And not really understanding how much data is needed for your AI project is an issue. A lot of people always ask us, well, how much data do you need? And isn't more always better? And we say, well, not necessarily. You have to go back to what pattern of AI you're trying to solve. If you're trying to solve a conversational pattern, maybe you don't need as much. If you're trying to solve a recognition pattern, maybe you'll need more. So it's important to understand that. And it's also important to understand that, if you don't understand your specific types of data that you need for the project, then you can run into issues pretty fast. So if you don't really know what problem you're solving, say you just want to use, AI, you're being told you have to use AI with the Walmart example. Well, if you know it's a recognition problem that you need, you want to make sure that you're going to have, images of the items that you're trying to look for. So you don't need items on everything, right? We don't have cars in Walmart stores, so we don't need images of that. And we also want to make sure that we don't have, images of just unnecessary things because it's going to cost money to get all of that in. You need to understand if you have access to this data as well. Just because it's at your organization doesn't mean that you have access to it. Data silos still are real. And you also want to make sure that you have enough data to train these systems, but not too much data that you're, making it overly complicated, training it on items it doesn't need to know, or training it on noise. On the flip side of this, we have data quality issues. So we know that not all data is created the same. You can have, poor data quality, especially if it's coming in its raw format. It could have errors. Also, if you're going into the project before you even know what your data needs are and the quality of that data, and you're training it on that garbage, we said garbage in is garbage out. You don't want to be training it on quality data. And you also have to understand what your real world data looks like, especially compared to your training data. When you're going to train these systems, you're most likely going to be training it on really high quality, good data. That's like a gold standard. And when you go out into the real world, data is just going to be a lot messier. So we do always like to have these ripped from the headlines because we like to show you how this is happening in the real world and how things can fail if you aren't prepared for this. So ImageNet is a very popular, image repository, and it was found out that about 5% of their images have errors with their labels. So over here, there's an image of a deer that's mislabeled as a magpie, and a magpie is a tiny little bird. They don't look anything alike. If you don't have access to that data and it's, and it's not all good quality, then it can cause issues in your results. Another example that we have is a lot of people are getting so excited about what large language models can do, and they're using it to help with a variety of things, including writing books. But you have to be careful because they were writing books, people decided to write books about foraging and picking mushrooms. And if you do that, you know that some mushrooms are edible and some mushrooms are not edible, and they may look very similar. When you're out foraging in the middle of the woods, you might not have connectivity to the internet, and you're relying on a hard copy of a book to be able to help identify different plants and species. So it was found out that some books that were written by AI had poor quality data and were telling people to pick mushrooms that actually were poisonous. So you do need to be careful. And then another example we have here is Rite Aid, which is a retailer in the United States, was banned from using facial recognition after it was discovered that they were falsely tagging customers as potential shoplifters. And the store employees were, then taking action on that while they were using very poor quality, grainy security camera images on this. So, really understanding data quantity, how much you need, and data quality, how good that data is when it comes to AI.
This brings us to the next sort of failure mode, or if you will, something insight here with data with AI projects. Let's mention that the majority of time that we're going to be spending with our AI projects is really around data cleaning, data preparation, data collection, basically all the data engineering parts of the AI project, because AI systems are so dependent on AI that if we don't spend our time with the data, we're going to have garbage in is garbage out, which is the real problem here. We only get to spend 10 to 20% of our time on the fun parts, which are running and building the AI model and putting the AI model into production. So when we think about that, you think about it in terms of time and cost budgeting for AI projects. Sometimes we don't budget enough time or resources for the data preparation. And if we shortcut the data preparation, we end up getting output results that are very poor. So that's sort of a little insight there into the AI projects and really focus on the data part. So another sort of reason why AI projects often kind of fail is that we run into this thing called the proof of concept trap, which is we always want to, prove that the AI systems can do something interesting, which turns out to be really easy to prove with AI. If you think about all the models that are out there, we can do lots of natural language processing stuff. The GPT things are amazing. And so we say, oh, look, I can do this thing. And then the moment we try to actually do something in production, we find that we can't do that simple thing doesn't work that well in our real world. And that's because the proof of concept is really not that useful for AI. We don't really want to prove a concept. The whole value of AI is testing something with the dirty, messy data that's in the real world and seeing how well it performs. And if we don't do that, we really haven't proven anything. And the other situation is that we really want to be focusing on very quick iterations. As you probably have noticed, AI, especially machine learning models, iterate very quickly. Today, we might see a model that has come out that's been updated from something yesterday, the previous month. Things are moving very fast, which means we need very fast iteration times. The faster, the better. That means that we can't be affording to do things in sort of a lab environment that has the perfect data with the perfect usage scenario. Instead, we need to be working with it as much and quickly as possible in the real world. So we need to push towards those pilots. We see a lot of projects fail because they were spending too much time in sort of this protected lab environment, and then they go put it in the real world and it fails. We've seen projects that are like 12 months long. We're like, that's way too long for AI projects. You really need to be getting quick iterations out as fast as possible into the real world. Actually, I have a question on what is data engineering, but maybe Kathleen will talk a little bit here. I can talk a little bit about what data engineering is right after that.
Sure. Yeah. So basically we just say, be careful, proof of concept, whenever you're doing a proof of concept, you are going to have a very, closed environment. People are going to be working on this who are closely tied to that project. It's going to have that best data. And then when you go and put it out in the real world, you're going to run into issues. And so this failure reason actually ties in nicely with the last one. And it's that the real world doesn't match your model. So we just said, the real world is a lot more variable and a lot messier than your training data, because you're taking that data that you have, making it clean, really, spectacular data, but the real world isn't like that. And AI models are sensitive to all sorts of inputs that maybe you've never tested for before, which is also why we want to have it in pilot and not a proof of concept, because you want to see how it's being used in the real world by people that aren't so familiar with your project and people that aren't so, closely coupled with this. And AI models can fail in some pretty spectacular and harmful ways. So we have to be really careful about that. And that's why we want to see how it's working in the real world. It's always, always important, no matter how much you want to rush this out, that you are testing your models and making sure that they are performing the way that you'd like them to. AI implementers often skip this model evaluation step, and we'll get into model evaluation a little bit later. But really, it's just we take our model, we build our model, and then we need to test it and make sure it's working the way that we expect it to test before we go out and put it in the real world. Move fast and break things is a very popular Silicon Valley slogan, but it doesn't work well with AI. So Andrew Ng, who is an AI luminary in the space, was working on a model for radiology images, and he went to a world-class Stanford hospital that had the best imaging, the best devices there. And what he said is that it turns out that when you take that same model, that same AI system, to an older hospital down the street with an older machine, and the technician uses a slightly different imaging protocol, the data drifts to cause the performance of AI system to degrade significantly. In contrast, any human radiologist can walk down the street to the older hospital and do just fine. So what they could have done here is said, if we know that we have this high quality, system that's producing very crisp, great images at Stanford Medical, but the hospital down the street is using an older machine that has a slightly different, quality of images, maybe we should test it there. That's what happens, bring it to the pilot, bring it to the real world, so that if it had failed, they would have learned and been able to fix and evaluate their model at a much higher rate, so that they weren't doing all of this work to then put it out in the real world only to realize, wow, it's failing in some spectacular ways.
Yeah, and just to the question that was earlier asked about data engineering is sort of the collection of tasks that we need to do to basically make data available for any sort of data use. It could be analytics, but in the case of AI, it's to make it available for AI. So it's things like data preparation, data collection, data annotation, if I need to do that, data preparation in all of its various different ways. And then also it's called the construction of data engineering pipelines. That is moving data from their original sources or where they are into the places that we need to make them operational and use them for training data. And one of the things that we spend a lot of time talking about, especially in our training and our CPMAI training, which we'll get into later, is that you actually want to be building those data engineering pipelines even before you start building your AI systems, because the need for data is so precious that we can't really afford to have bad quality data. So we should be spending our time building and managing data engineering pipelines more so than even just building the models. And many times we're going to be using other people's models anyway. So the data turns out to be pretty much the only thing we're spending most of our time working on. So this sort of does bring us to the next sort of reason why a lot of AI projects fail, is that people don't realize that AI systems are constantly changing. The data is constantly changing. The way we use the AI systems are constantly changing. The world is constantly changing, as we all know. So we can't really have what's called set it and forget it, where we just build a model and it worked today, so it'll work next week, next year, next month, whenever. We need to always be constantly updating it. And that's because, as mentioned, the data changes, the real world changes. AI models are not deterministic. That's like you don't always give them the same inputs and always get the same outputs. Because if you wanted to have a deterministic system that had inputs always going to outputs, you don't need AI for that. We can just build a rules-based system or programming or something like that, because we wouldn't need intelligence. We use intelligence specifically because of the probabilistic problems. That is, the inputs don't always look the same, the outputs don't always look the same, and things are highly variable. Well, because of that, that means that the AI systems don't always provide the same results, even for the very same input data. You may have experienced this with prompting and prompt engineering on LLMs. And so as a result, we have to always be aware that there may be a chance that they produce something that's undesirable. And as a result, if we are not keeping track of it, that could get worse over time. And so AI projects usually fail because we haven't budgeted. We haven't spent the time or the resources necessary to constantly manage and update these AI systems to deal with the change. And we see lots of examples of companies getting into trouble when they just put an AI model into place and say, well, we'll just sort of leave it alone. What bad could happen? The answer is, well, quite a bit.
Exactly. And so because we say it's never set it and forget it, and it is probabilistic, not deterministic, which means you can't just, code your way to telling it to give the same answers every single time. You need to be careful. A lot of organizations are it's very tempting to now just put a large language model on your site and you instantly have a chatbot. But you need to make sure that the results that it's providing are accurate and that you are constantly testing for this. That's why we say it's not a set it and forget it. You don't just go put something on your website, that's AI enabled and say, it's going to work just fine. I never need to look at it again. Air Canada recently got into a lot of trouble and they were taken to small claims court because they put a chatbot on their site and the answers that the chatbot was providing did not match the answers on the website. So somebody had a question around bereavement and what their policy was. The chatbot gave one answer. Their website actually had a different answer. And so they were taken to small claims court and actually Air Canada lost because it was, the person that was asking the question didn't know that they needed to go to the website for the most authoritative information. What Air Canada could have done is said, for anything related to, payments or refund policies or, anything money related, the chatbot is a helpful guide, but you need to refer to the website. But instead they didn't do that. And so that's why they got into a lot of trouble.
Right. So this sort of brings us to another common reason for AI project failure, which is that the products don't always match what we're trying to apply them to. And sometimes it's because the vendors, hype up their products. We see this a lot with AI because AI is so exciting. And, people like to add AI features to their products because maybe it increases their shareholder price, or maybe because it makes people maybe more interested in buying their projects because they sprinkle a little bit of AI magic dust on that, even if the product is doing exactly the same thing it used to before. So there's certainly a lot of that. So you can maybe blame the companies who are selling and marketing their products. But a lot of times, honestly, the companies don't make too many claims about their products, but people apply the products to the wrong problem. We see this a lot with ChatGPT and large language models. When I see comments all the time on LinkedIn saying, "Oh, I tried to get ChatGPT to answer a math problem and it didn't work," and I'm thinking, why did you even try to do that? It's not really. It's a large language model. It predicts the next words that should appear, and it treats numbers as words. It treats numbers as tokens. It doesn't actually treat them as numbers. And besides, why didn't you use a calculator? So, again, this is the sort of like just a quaint example, but it's an example of applying the wrong solution. Not every problem is a conversational problem. Therefore, we don't need a conversational system. Some things are a recognition problem, or some things are an analytics problem. We can use something else. And when people try to misapply the technology, of course, we should not be surprised when things fail, because they're not intended to work that way. So obviously it doesn't work that way. Now, we've seen even whole companies fail because even the company thought that the technology could be applied in a specific way, and it wasn't. This is the reason why IBM's Watson Health just completely went away. The problems that they were trying to solve just could not have been solved with AI. Maybe there were people and process problems. Maybe there were some other underlying problems, but either way, the AI systems could not solve them. And of course, we see lots of examples in the press of, these products being hyped. And I think it's really up to all of us, the users of the technology, to know, one, whether the claims about the technology matches their capability on the one hand, and two, even if it does match, whether we're applying the problem to the right, the solution that is to the right problem, and maybe whether or not we even need that solution at all. We can do it another way. And of course, we have the other issue of maybe we have too much of a dedication to one particular vendor. We are a X vendor shop, so we only work with this vendor for all solutions. And maybe that vendor is really good for certain things, but not so good for other things.
Exactly. And this also really comes down to, what problem are you trying to solve? Because if you don't know what problem you're trying to solve, you don't know what solution is going to be the best for the particular need. So that's also why things can happen where maybe you've bought a product that is a really wonderful product. It's just not good for what your problem is. And that's where you can also get some of this mismatch. We have a question that goes back to the previous slide, which is about life cycles. And it says, please elaborate on life cycles are continuous. How will this affect costing? And the answer is, yeah, because it's not a set it and forget it, you need to make sure that you do have budget to retrain your model as needed, and to make sure that you are constantly monitoring that. Now, that depends on what it is that you're trying to do, whether and how often you're going to need to do that. But you do need to make sure that you are budgeting for that. And that is where people get into trouble, and organizations, because they don't budget for that. And budgeting can be people, resources, and money. And if you're not budgeting for that, with all of those factors, then that's where you can run into issues.
Right. And this is also why scope management is important, because if we have if we're trying to bite off this big problem, and at the same time I'm trying to do continuous management for it, that means I could have a possibly really big ongoing cost, especially if we have to manage data engineering pipelines, all that sort of stuff. That's why controlling scope is so important with AI projects. Even though it might not seem that grand to only focus on one aisle in the store, the answer is, well, yes, but then at least you can build your processes and build your systems and see how much the ongoing iterative cost really is before you do things for the whole store and all the products. We also have 2 open questions, by the way. I think we will get to them in the Q&A, one of which I may or may not have an answer for on awards from PMI for an AI project, so we could talk about that. And the second one is, what are the best tools to implement AI onto construction projects? And so we'll hold that for the end, because there's a lot of different ways that we can go on that question as well. But I want to acknowledge your questions. Yes.
So another common reason that we see is falling into the uncanny valley. So the uncanny valley is a relationship usually when it comes to physical objects. So it's the relationship between the degree of an object's resemblance to a human being and then your emotional response to that object. So if we look at these toasters, for example, we have a pretty cute toaster with just a little smiley face. Maybe we can make the smiley face a little bit bigger. We're like, okay, that's cute. But now we've started to make the face look more human-like. And we go, that's making me feel a little weird. And now we just put a human face right on the toaster. And we're like, okay, I am totally creeped out. I don't feel good looking at this. Something looks off. That's where we've dipped into the uncanny valley. And then we're back up to feeling normal again when it's an actual human. So this is with physical items, but the same thing happens with data. And so as organizations are collecting more and more data on individuals, we talk about that hyper-personalization pattern. You want to treat each individual as an individual. Well, maybe you go onto a website and it greets you by name. You're like, oh, that's really nice. It knows who I am. And maybe it's remembered your previous search history, or it's recommending useful products to you. And you're like, okay, this feels really great. But then it recommends something. It goes, I know that your neighbor did this, and so maybe you should do this. Or someone in your house did this, and you should look into that. This looks weird. And you go, wait, hold on. You're starting to know way too much about me. I just went onto a website because I wanted to do some browsing, and now you're recommending, things to me that I never asked for. I don't feel comfortable anymore. I have dipped into the uncanny valley. When you do that, it's really hard to just about impossible to get out of that uncanny valley, which is why you want to go right up to the line, but not go into it. And this is where organizations struggle, because you want to provide that, personalized experience, but you don't want to go too far that then you dip into that valley.
So we like to say people might get creeped out. So some people that's pretty creepy. Whether that's the Sophia bot that looks creepy, or it might be the data knowing too much about you that's creepy. And if you've done that, then it's easy for people to basically not want to interact with your system at all. And then, as Kathleen mentioned, hard to get them back. So this leads us to really one of the biggest reasons why AI projects fail, and we constantly do this since the 1950s when we first started, developed the AI concept and have been building our AI systems since then, is that we overpromise on what these AI systems can do. We say, oh, it'll drive cars automatically, and it will, answer any question you have, and it'll translate every language, and it'll do all that. Well, certainly, as we iterate with our AI systems, we're getting better and better at that. But when you require that the solution actually be able to do that, and the system is not ready to do that, then of course the projects fail. And so this is really an issue of mismatched expectations into what AI can do and what it can't do, the limitations of AI, setting realistic expectations, and of course, scoping. That is, yes, maybe we do have a big idea for what we want this AI system to do, but maybe we should start with something smaller and simpler just to see if it can do that. We should probably start with something that is a real problem that we can solve today for that. So there's a lot of things that we can ask ourselves when we are thinking about our AI project that can help us avoid, hopefully, over-promising what the AI systems can do and under-delivering as to what they can actually do.
Exactly. So the first question we have to ask is, why are we using AI? That's an important question, and not everybody asks that. You want to make sure that you understand what AI is good at and what it's not good at, and then apply it to something it's good at. Hint, the 7 patterns of AI are what AI is good at. And if it's not within one of those 7 patterns, then maybe it's not the best solution. And you may feel a lot of pressure to be doing AI. You think that your competitors are doing it, or you're, being pressured from upper management, but that's not a good reason to do AI. You want to make sure you're solving a real business problem that AI is best suited for. And are we promising too much from the AI solution? I mean, we talked about how over-promising and under-delivering is not good, because we over-promise on what we can do. We get so excited about it, and then we don't deliver on that, which means we've spent all of this money, time, and resources on a failed project. And are we more invested in doing AI than solving the problem? So, you're just caught up in that hype of doing AI, and you're not actually really trying to solve a problem. And that also makes you need to ask, do you even know what problem you're trying to solve? That is incredibly important. Don't move forward with a project if you're not actually solving a real problem for your organization. And when you're thinking about this, you have to say, what am I trying to do? And then why are you trying to tackle the hardest possible problem first? That Walmart example we brought up, they were doing 2 different patterns, the recognition and the autonomous pattern. If they had just started with the recognition pattern, they might have gotten better return on investment. But because they combined it together, and the autonomous pattern is the hardest pattern, it's just going to cost more. There'll be more, more involved projects. And so why are you starting with that? Make sure that you're actually solving that problem. And maybe you never needed to get to the autonomous pattern. And then why are you trying to tackle too many patterns of AI at the same time? We said that your project can be more than one pattern of AI, but we always say think big, start small, and iterate often. So think big about the whole project, but then start small and start with just one pattern of AI and move forward with that. And then you're going to continue to iterate.
So this brings us to making AI projects a success. And we talked about all these reasons why AI projects fail, and it may not come to as much surprise that it's not we just need a better product or we need better technology. The technology is getting better every day. And there's lots of great people working on great technology, but we just showed you examples of people who even had the best technology and the best researchers having these problems, whether it's Andrew Ng or Walmart or any of these examples. People have lots of resources. So clearly, as you know, there's three things we need to make these sorts of projects succeed. On the one hand, we need technology, but we also need people and process, right? The three-legged stool to support all of this. And a lot of these problems can be solved with better process. And that is that methods and methodologies for running and managing these AI projects so that we can address the issues of making sure that we are solving a real problem, running AI projects like data projects, managing data quality and quantity issues, aspects of vendor fit, issues of over-promising and under-delivering, and the aspects of implementing pilots and not proof of concepts and doing so in the real world in really fast iterations. Some of these things may seem very familiar to you as we've been doing iterative projects and agile projects, but we hadn't really thought of them as data projects. So in the last part of the 1990s, early part of the 2000s, well over 20 years ago, there was an approach, a methodology called CRISP-DM that was around for running big data projects. And that existed because we needed a way to get, we were doing all these things at once. We were doing Y2K, if you remember that. We were implementing ERP and CRM systems for the first time. We, of course, had the internet. People were establishing e-commerce systems, and we had this big move to get more data from our systems. The problem was, we didn't have cloud computing back then. We just had big enterprise data systems, and we had to get these systems to churn on data. And sometimes it would take like a week or two to get the analytics that we needed. So we needed a rapid iteration process for getting the results and not waiting until the end before we realized what question we needed to answer. And so that was CRISP-DM. And the thing is, though, it had been abandoned for the last 20 years. And as I mentioned, in the last part of the last decade, us, a bank, and some government institutions were looking to find a way to implement AI systems in this predictable, reliable way that would improve not only the rapid delivery of AI systems, but do so with the lowest possible risk. So we looked at CRISP-DM, realized it needed an upgrade, and basically created a methodology called CPMAI. So CPMAI is the Cognitive Project Management for AI methodology, and it follows basically 6 phases in an iterative approach. The reason why it's a wheel in this shape is because as we go through each of these phases, we may realize we may have missed something from an earlier phase. For example, when I'm preparing the data, I might realize that I misunderstood what data I needed. I'm allowed to go back a phase. I don't have to continue through that whole cycle to the end before I go back and solve an earlier problem. So it's a highly iterative methodology that focuses on trying to build AI projects with high degree of success in rapid iterations in the real world using the data that we have to make it work. So let's provide a quick overview of the 6 phases of the CPMAI methodology.
So phase 1 is business understanding, and this is what problem are you solving? That's the question that you need to be addressing. Within this phase, you will have AI business requirements and KPIs. You'll also go through an AI go, no-go, which is a series of 9 questions that you need to address and answer. We think about it like a traffic light. So if it's green, that means great, you can go and move forward, you're ready to begin. If it's yellow or red, we say, pause here, and we're not telling you not to move forward with the project, but if you do, then your chances of failure are going to be higher. And we also want to bring in trustworthy AI requirements in phase 1 business understanding, because we want to make sure that we're building trustworthy AI systems. Phase 2 is data understanding. So now that we know we're solving a real problem, in data understanding, we say, okay, what are our data requirements? What are our data sources? Where is all our data coming from? Is it internally? Is it externally? Is it a combination of both? What's our data quality understanding? Because we talked that was a common reason AI projects fail. So let's make sure that we understand how good our data is, and then our overall data environment. Phase 3 now is data preparation. So in this phase, we're going to be collecting data and ingesting it, cleaning and preparing it, and labeling it and annotating it. We had presented earlier about how 80% of AI projects are data engineering projects. So your data phases are going to be a large portion of your AI project time for that one iteration. So it really is important, and as Ron mentioned, these are iterative, so you can go back. So maybe as you're preparing your data, you realize that, you need to go back to data understanding, or maybe you need to go back to business understanding, and you can, but this is where the majority of the, time for each iteration is going to be around that data. And
So
then we
this-
have,
Yeah, the next 3 phases. So ideally, once we've gotten to phase 4 of CPMAI, we've already know what problem we're trying to solve. We make sure it's a problem we can solve with AI. We've identified the pattern. We've also addressed many of the AI go, no-go points to make sure that we don't run into any sort of roadblocks that will prevent us from implementing AI. And we also now have a data understanding. Now we know the problem, we can scale it, focus on the primary problem we're trying to solve. That leads us to a better understanding of what data we need, especially if we know what pattern we're solving. Then we can figure out from the pattern what data we need from it, as well as knowing where the data is, do we have access to it, the sources of data, and of course you can prepare that data for the model. That of course leads us to now we are ready. As I mentioned, that's 80% of the project right there, those first 3 phases. Now the remainder 20% is picking out the model. Maybe I'm building my own, or maybe I'm using an off-the-shelf model. Perhaps I'm doing prompt engineering, or I'm doing some extension of a model, or maybe I am building a whole model from scratch. But now I have things in place that I can actually do that. I can train the model, or I can extend the model, or I can do engineering, whatever I need to do, fine tuning, and then I can maybe combine these models together if I need them to work together. Then I can move to the next phase, which is before I'm ready to put it in production, I need to test it in the real world. We said that was a common reason for AI project failure. So in phase 5, we can test it against whatever our key success criteria are, against real world data. We can check their performance, and we can adjust and tune that model to perform as we need to. And then we are ready to put the model out, get the real world people working with the real model, and called model operationalization. But that doesn't mean we're done, because there's no set it and forget it. So we're going to implement some way to monitor the tool and manage it, the model, to make sure that it's actually continuing to work. And of course, do whatever retraining and ongoing modification to make sure it's continuing to work. And we can do all of these phases iteratively. So we go through these whole set of 6 phases through each iteration. So the first iteration may only be 2 weeks, which means we need to focus on scoping the project, because as we said with data, a lot of data is good, but too much data means too much to prepare. Too much data means a large data engineering pipeline. A large scope means we have to do a lot of continuous management and continuous training. So focusing on scope is really very important. So that's basically the core of it. And, if you want to learn more about CPMAI, we have a variety of ways to learn. And of course, as you might have guessed, we have put a lot of organizations through CPMAI training and certification since 2017 for folks who are looking to manage and run AI projects, not only for themselves and their organizations, but even on behalf of others.
Exactly. So we have just for you, you can go to courses.cognilytica.com and use code PMI 2024 for 10% off any of our CPMAI certifications. This really is a best practice methodology for running and managing AI projects. And we also have a free intro to CPMAI course if you're interested in learning more about CPMAI and digging a little bit deeper. Both of these courses are self-paced and virtual online, so you can take them at your own pace. If you're interested in this free intro, you can go to aitoday.live/CPMAI, and it will give you 3P to use upon completion. So with that, I know that we have a bunch of questions and we will get to all of those. Thank you so much. If you'd like to reach out to us, you can do so by emailing us at team@cognilytica.com. You can also find me and Ron on LinkedIn. And if you'd like to listen to our podcast, you can go to aitoday.live. Like I said, we have over 400 episodes on a wide variety of different topics.
Yep. And so we have a couple of questions here. Someone asked about the PDO claim code. That's actually in your webinar chat. So Go look for the chat in Zoom and you'll see the claim code. I could say it out loud, but it's a lot of letters and numbers, so be aware of that. So we have a couple of other questions. One question, so is there an award? So this is from Nujad Huraib, who asks, is there an award from PMI for an AI project? So I wasn't entirely sure what that meant in terms of an award. Are you talking about a certification or an award in terms of some sort of recognition? Maybe if you want to clarify in the Q&A, you can. Sorry, maybe someone else can chime in here on that one in the chat or in the Q&A to help me with that one. The next question has to do with implementing the best tools to implement AI in the construction. So the construction industry happens to be one of those industries that benefits greatly from the use of AI in the systems. Okay, so I got a clarification that the previous one wasn't an award, but was a certificate. The answer is not yet. PMI doesn't have one. PMI does recognize the CPMAI certification. So if you're interested in getting CPMAI, I think when you get CPMAI, it's something like 33 or 38 PDU. So you get quite a few, at least 30 with the CPMAI, and it's recognized by our colleagues there in PMI Global, who we know very well. As for construction, there's many places. So so think about all the patterns, right? All the patterns of AI. So on the first area is the whole conversational pattern. So anything that has to do with documentation, reporting, scheduling, analysis, all of those things can be facilitated with AI. You can use AI to generate reports, analyze reports, automatically keep track. You could take, let's say, databases that have data sources and generate from them reports that you can read in any of a variety of languages too. So, it doesn't have to be, you could pick 1, 2, 3, 7, 8 languages, generate reports in multiple languages at the same time, do an analysis on that. You can do cost benefit analysis. We actually have worked through an example on that fairly recently. Scheduling, look at meeting notes, automatically do all that sort of stuff. So many ways of doing that. Then there are the other patterns. You can use AI for predictive analytics. Take a look at a schedule and automatically figure out if things are running on time or slipping, what the bottlenecks are. There's many applications around recognition, people using AI, the image recognition for things like security or managing safety on job sites, or being aware of people coming in and leaving, looking at resource piles and seeing how many they are. We actually did a whole article on AI in construction and all these ways, and I'm sure I'm missing
and we have some podcasts on that as well. So I encourage you to go look at our podcast, go look at some articles that we have either on our site or on Forbes for that. Yes, because there are also, I know, scheduling. We've seen AI being used for scheduling. And so what you can do in general, and we always say this, is that figure out where your pain points are and then look to see how other industries have done that as well. Because maybe your scheduling needs are very similar to other project manager scheduling needs in other industries. And so see what tools they're using. So some are construction specific, but then others are maybe more application specific.
Yep. And I have a few articles here and a few podcasts. We'll share them here in the chat, but I think we'll also share them afterwards with your hosts here at PMI chapter KSA, so we can maybe share them with everyone. But I have a few of them here, and I can post as well. And I think we have a Forbes article as well that we wrote. And
I think we do. Yeah, we have a bunch. And I know we had some interviews. We also had some podcasts. So perfect. Yeah,
yep.
Great.
Yes, and so there's a question about estimating time and cost for a project with all of this uncertainty. And that is a key. That's why project managers are still needed, because it's not like a formula. If it was a formula, we wouldn't need managers. But the answer is that the general CPMAI approach, the very first step, the very first thing we do when we do business understanding is we try to basically find the smallest project that we can implement in the fastest amount of time with the highest degree of return that meets this overall big problem we're trying to solve. And when you do that, when you carefully narrow down that scope, it becomes obviously a much easier problem to do a cost and time benefit, especially if we're focusing on a 2-week iteration. At least we know what what the time will be, 2 weeks. And we kind of can limit the cost to some extent. The thing is, as you get more experience, you start gaining a little bit more expertise on knowing how much the data aspects cost, data collection, data cleansing, data augmentation, if that's needed at all. And you also get some idea of the time frame it takes to go through a full iteration. But that's why, scoping is really so important, because otherwise it does become a very difficult prospect to figure out how much time and how and cost it really will take when we have such a big problem. We're trying to do multiple patterns at the same time. We don't have a good understanding of our data, the data quality. We don't know how much it's going to take in terms of the time and effort to clean that data. So if we do smaller projects, we can build that expertise faster and gain much more understanding of that. So hopefully that helps a little bit. There are some additional approaches we provide as part of the training and certification in terms of methods for basically doing project time and cost analysis and scoping and that sort of things. But it does depend a little bit on the pattern you're using and things like that. So hopefully that has helped you on that. I think there's some questions going back and forth on the chat, so hopefully I know some of this as people are answering. And thank you very much. We really appreciate you all being here. We really thank you for your time and inviting us, especially to participate. There's one more question from Ahmed Khalifa, who asks, what are the common roles that are usually needed for AI projects? Specifically image processing, generative AI projects on a small scale, AI engineer. Very good question. So it was in the past, you needed more roles because you needed machine learning engineers and data scientists, usually to put together the models and to actually train the models. But now that we're going to be using so many of these models off the shelf, it actually turns out you don't need as much in terms of machine learning engineers, because you can use an off-the-shelf model, especially for image recognition that you're talking about, image processing. You can use these models like YOLO and Inception and all these other ones that are already available that might do a good job, or maybe you just need to extend it a little bit. So the most common roles have generally been, besides the project management roles and the business level roles, that you need in an organization. You will need some data management, whether it's actual data engineering roles, people who can manage, especially for image processing, which is very sensitive to the training data that we're using and the live data. You need to build that data pipeline. So data engineering roles across the board are incredibly important. And for those, if you're using a third-party model, you do need someone who knows how to interact with the third-party model. So that could be, someone who's had a data scientist or machine learning engineering role, or maybe even a light role who just knows how to use the APIs to get data into and out of those models. Those can work as well. Turns out that the team sizes are becoming less and less large because there's so many good models that are out there. Now we just need to know how to use them or extend them as possible. Hopefully that helped as an answer. The question about slides. Yes, the slides and replay will both be available here on Zoom. It's being recorded. We know that. So they'll be shared. And I think last question, I think, is the risks. I know we're slightly over time here, so maybe Kathleen, you want to answer quick. What are the risks due to possible risks of using AI in project management?
Yeah, I mean, I guess, when you're asking for risks, are there's a lot of fears and concerns when it comes to AI. And I guess, the risks are really making sure that you understand what AI is good at and how it can help augment your job and your role as a project manager, and how can you use it to, maybe get rid of some of those tasks that you don't like, that are very tedious, that are taking up a lot of your time. A lot of people ask, how are project managers using AI for their job? And we also are addressing, how do you run and manage AI projects as a project manager? So there are two, different sides to how project managers need to be thinking about this. So when you're looking to run an AI project, if your organization wants to do that and you need a step-by-step approach, we say definitely look to the CPMAI methodology. If you're looking about how AI can be applied to project management in particular and what some of those risks are with that, just make sure that you're applying the right tool to the right problem, and also understand its limitations so that you aren't doing all of these things we talked about, right? Over promising and then under delivering on what it can do, and not having it really be a solution, but just causing more issues.
Pretty much all the failure modes we talked about here.
Pretty much.
Of course, we know that AI systems are probabilistic. So just be aware that you might not get the results that you're looking for. They might not be predictable. AI systems can also make things up, hallucinate. We have issues with data bias, data ethics, lots of issues around data privacy and security. There's many things to consider. We have a whole unit on the trustworthy aspects of AI, but hopefully if you at least focus on things we talked about here, in this session, you will avoid some of the other common risks of AI and project management. So on that note, want to thank you all so much. You guys have been fantastic. We appreciate you sticking with us, even a few minutes late. This was actually, I think, one of the best attended PMI chapters
Sessions,
we've ever done. So we really want to thank the organizers for bringing this to your attention and getting you all here. And thank you so much for spending time with us. We really very much appreciate it.
Thank you very much, Ron and Kathleen. And actually, it was very interactive and very awesome and astonishing session. And especially, it is touching one of the hot topics nowadays, which is artificial intelligence and how we need to deal with AI. We really appreciate your session here. Thank you for the information that you have shared with us. And hopefully for the next few months, next few weeks, we have another session with you guys for more and more information about CPMAI. Really appreciate your presence and sharing your knowledge. And I would like also to appreciate all the attendees and the participants who attended this session. And I would like to remind you that the PDU code, it has been shared in the chat, and I will share it again. Also, I would like to remind all of the guys, Ron, Kathleen, and all the participants that we are going to have a global project management forum, which is going to be here in Riyadh in the month of June. So we are eager and we are thrilled to meet you there to learn more and more and to engage and to interact with each other, socialize, learn more about project management, artificial intelligence, and how we could achieve more and more in our career life. And we build our nation nationally or internationally in order to provide quality service and quality products to our consumers, to our customers, and to the humankind. We really appreciate you, Ron. We really appreciate you, Kathleen. And hopefully we are going to meet you in Saudi Arabia. And as I told you before, mi casa tu casa, you are invited. And I am quite sure that you are going to enjoy staying here in Riyadh if you are planning to come and visit in our Global Project Management Forum.
Absolutely. Well, thank you so much for the invitation. We look forward to it. And I look forward to
for sure.
with you.
Okay. Thank you very much. And this is the end of our session. And I wish you a good morning, good afternoon, and good night for the people who are in Saudi Arabia. Thank you very much. Appreciate it.
Yeah, thank you. Bye, everybody.
Thank you. Bye.